All right, so this is a section 6.2 practice, and it's all about sequences involving dilations. And so we have our first image here, and then our first pre-image, and then another pre-image to this image, right? So this is our first transformation. This is our initial one. This is our initial one, and this is our second one, and this is our final one. So this is our first, and then it transforms into this, and then it transforms into this. Okay, so that's what's going on here. Okay, and you can tell because of the single prime. Maybe zoom in a little, you can see it better. So you can see it's no prime, then a single prime, and then a double prime. All right, so how can we figure out, without the use of padding paper here, what happens first? Okay, well, the first thing that happened from W here, from this one to this one, I'm just going to pick one of these accesses here. So from 1 to 2. So from 1 to 2, what happened? Well, I'm going to pick the easy one here. So my y coordinate to my y prime coordinate, what happened? Right, well, so my x value was -2, and my y value was 8 for that. And now my y value for y prime is 2, and then my x value is still 8. So my coordinate comparison is the x's and the y's stayed the same, but my x value changed state, so that's -x comma y. And I remember from my algebraic expressions that is a reflection across the y axis, because my y values stayed the same. Right, my x values flopped, and my x's and my y's stayed the same. Right, so my first one is a reflection across the y-axis. Okay, well, the next one is saying, what is the scale factor from this dilation, and what is the point of dilation? So I'm going to shift to pink here, and I can see, we figure out what the scale factor is. There's a number of ways I could figure out the scale factor is. And let me see. First, figure out the dilation point. Well, figure out the point of dilation. I'm going to just kind of do this with that one, with z here. This is probably the points that I'm going to use to figure that out, the dilation of the point. Right, and then I'm going to line up these, and hey, look, and lo and behold, there. And so it looks like my point of dilation is centered at T. That's my point of dilation. Well, what is the scale factor? Well, I can remember my scale factor. Scale factor equals is some points, some variation of my after divided by my before. Okay, so I'm going to go ahead and I'm going to do, I'll do my x value, my distance from y, from the point of origin, my y distance, my y value after divided by my y value before. Okay, so my y value after is 6 equals 6 divided by my y value before, which is 3 for this point z. Z prime point z. Okay, so that's just the y value, right? That's good enough to figure that out. Now that's going to be, oh wait a minute. Oh, this is my after. This is backwards. This is 3 and 6. Yeah, so this is z prime, and z double prime. So z prime is z double prime before my after and my before and after. Oh, wait a minute. It shrinks, so it should be less than 2. So let me figure out something else here. All right, so I'm gonna do, let's do this line. I'm gonna do this line here. Do this line here. Okay, so this line. Okay, let's turn it to green. This line and this line. There we go. That line and that line. Okay, so, all right, so then my difference for my YZ is going to be my after is going to be Z prime ZY double prime divided by Z prime Y prime. Okay, so that's going to be Z prime Y prime. It's going to be, let's see, 1 squared plus 1 squared equals 1 squared plus 1 squared square root of that. Okay, divided by, okay, so here we have, let's see, this is 2 squared. This is 2 squared plus 2 squared, square root of, oh, I have this flip-flopped, I think. After is this one. It should be on top. Double prime's on top. Square root of 1 squared plus 1 squared. That's on top. Okay, my before is the square root of 2 squared plus 2 squared. It's going to be equal to the square root of 2 divided by, let's see, 4 plus 4 is 8. That's 2 square root of 2, right? Which equals 1/2. Okay, so my dilation factor is is 1/2. Okay, so I just picked that one. That's the one I decided to pick. You guys can pick any one of these. It doesn't matter. I could do it with this one. I could do it with this one. I could do it with that one. But you also see I could have used 6 divided by 3. That would have worked too. That would have been 1/2. So 6 divided by 3 divided by 6. But 1/2 too. I could have used 2. My W value, my 4 about my Y, so my 4 is my 2 divided by 4. That would have worked too. So any of those would have worked. I just did it the hard way. Okay, so then, so what is my algebraic description for the reflection? Well, I have that right here, right? It's just x comma y is negative x comma y, and then for my reflection is going to be x comma y, and then it's my scale factor 1/2. So that's that. So there you go. All right, so determine the coordinates. Let me go zip up a second here. All right, so determining the coordinates of these things if first dilated then reflected. All right, so then we need to dilate this first. So if it was going to be dilated, then we'd multiply it by -2 or -1/2. sorry, multiply by 1/2. So we're gonna do this. Gonna be turned green. So it would be 2. So 1/2 of 4 is negative 4 is 2, and then 1/2 of 1 is 1. And if we reflected this across the x-axis, we would just change. We would to reflect this. It's going to be negative x comma y, right? So we're just going to take. It's going to be negative x comma y. So it's going to be the opposite of x, and then the y value. So it's going to be 2 comma 1. Okay. So the next one over here, it's going to be half of 8, which is negative 4, and then half of 6 is 3, and then this will be half of negative 1 comma 4, and this will be half of 0 is 0, and then half of 6 is 3. And then we just flip all the x value, all the y, all the negatives, all the x values to negative. So this will be 4, 1, and 0, and then we keep all these 4 and 3, 3, and that's 4. All right, so I took the opposite sign of this because it's a reflection across the y-axis, and then I kept the y value. This is a 4. Okay, and then based upon the both results, the sequence is commutative. Yeah, that means that it's going to be in the same spot when it's done. Okay. All right. You can look at 0 and 3, same spot. Y is 1 and 4. 4, x prime is 4 and 3, and then w is still 2, and w prime is still 2 and 1. So that means it's gonna be in, no matter if I did this one first and then this one, or this one first and then this one, they end up in the same spot. Okay. Then we have this one next here. Okay, we have QRS. Right, this is our first one. And then we have a single prime, which is that one. Then we have a double prime, and then we have a triple prime. So 1, 2, 3, 4. Okay, so so we gotta determine. Okay, QRS was first. It looks like it was rotated. Okay, so this thing was rotated probably about the. So if we look at R was negative 3. I'm sorry, negative 2, comma 3. This was R, and then R prime is 3, comma 3. So it was rotated and translated. This is 4, 3. Oh no, 3, 3. Okay, that's a bad one to do. Let's do S. S was 4, negative 1, comma 4, and then S was rotated to 4, comma 1, 4, comma 1. So that means it was the X and the Y is flopped. X, Y, X, Y, X, and the X turned negative. So this is a rotation clockwise. This is a clockwise 90-degree rotation. Okay, so it rotated clockwise. Okay, and then from here to here, it definitely dilated. Right? So it looks like from here to here, this is a 1. Let me go switch to green. The distance from here to here is that, and the distance from here to here is this. Okay, so my x value here, my y value here is 2, my y value here is 6, so it looks like a scale factor of 3. So it's 6 divided by 3. My scale factor looks like the scale factor is about 3. I'm not sure if that's true or not. Okay, so then we have this guy, and then it looks like it was translated. It looks like it was translated 1, 2, 3, 4, 5, 6, 7 down. So y equals -7 and x equals -1 over. It was then translated down. So yeah. So describe the transformation Q to QRS, right? So Q to QRS, it was a 90 degree clockwise rotation. So I'm just gonna say x comma y. I'm gonna make it blue. Blue is gonna be x comma y to y comma -x. That's a good one. And then the transformation from this one is going to be x comma y, and then it's going to be let's see, x y, and my scale factor was based upon the change in y is 6 divided by 2, right? Because it's the change in y. My final y value is 6. My initial y value was 2, and I just want to make sure it was based at the origin. I'm pretty sure that it was. So based at the origin, looks like it is. Yep, based at the origin. Yeah, so it's going to be 2. Okay. Dilation point origin, or 0, 0, right? And then transformation from here is going to be x comma y. It's going to be is now going to be x minus 1, y minus 7. Right, that's from up there. Okay, well, it looks like I already did. So this is going to be a translation down 7 and left 1. Okay, scale factor equals 2. All right, so let's see, down here is the transformation. This is going to be the clockwise rotation. And I already put it, xy is y comma -x. This is going to be the dilation. The xy is 2x times y, 2y. And then this is going to be the translation. It's going to be x minus 1 comma y minus 7. All right, just going to double check the enter key, make sure I didn't mess anything up. Got it. Got it. Everything is okay. It says it's 3. Oh yeah. I said 2. Well, it's actually 3. I said it 3 up here. But it's actually, and I wrote 2 down here. It's actually 3. I made it. Oops. Transcription error. So this should be 3 as well right here. So transcription error. All good there. Okay, so that's how you do it. Hope that makes sense.